We have conducted a user study where industrial experts used a domain-specific modeling language for industrial automation, and today I'm presenting some results from this study. First, I would, however, like to quickly introduce the language that we are using there. So this is standardized as 1499, and that's also the name of the language. And we have here blocks that are connected with events and data connections. So it's a graphical modeling language, and these blocks have implemented some functionality. And this application model is platform independent. We separately model then the system configuration and assign the application parts to the device they're executed on. And here I'm presenting a screenshot from the tool Eclipse Bordiac before we conducted our study, so about 1.5 years ago. There are several views that can be used for the implementing of an application. There is a system explorer on the left where users can see the hierarchical structure of their application. There is the graphical editor in the middle. As it's typical for Eclipse platform, we are also based on the Eclipse platform. There is a properties view on the bottom, and most actions are possible to do in the context menu. Of course, there are also some dialogues where users can perform special actions. And in our user study, we wanted to focus on tasks that are commonly required during working with existing software, because first, creating a project is a one-time task, and we really wanted to focus on improving the usability for common control software maintenance tasks. And we had 4 groups. The first one was to orient in an unknown application. So user got an existing application and they had to find, for instance, a motor. Then we asked them to create and remove some hierarchy levels, so for instance, an unnecessary grouping. But also they had to work with types with the library, so create a new type. Such a function block type is something similar to a class in a conventional programming language. And finally, we performed some basic editing operations, such as creating new instances of those types. And the whole approach was based on the cognitive dimensions, which allow developers who are maybe not experts in human-computer interaction to evaluate the tool. And that's also how we started everything. We took our own tool, and based on the cognitive dimensions, we evaluated the different aspects. Then we did a pilot study with a few participants to identify remaining bugs, but also to refine our instructions, how we present the tasks to the users. Finally, we had 10 automation experts from an industrial partner, and in a remote setting, they conducted the experiment. All the results were then grouped and evaluated based on each cognitive dimension. So we could then, after this multi-stage usability evaluation, define a couple of lessons learned that we think are applicable also for developers of other graphical modeling tools. And to give you a bit of insight, I would like to present a few cognitive dimensions and some examples. So when we had an application, that's how it one level looked inside our study. There are these hierarchical blocks, and when we look at them from outside, we don't know what's inside or whether there is even anything inside. And this tackles the cognitive dimension of visibility. And as one improvement that we did prior to the study, we have allowed our users to unfold this sub-application and to view the contents in the context of the overall application. Another cognitive dimension that is important is viscosity. So how many operations a user has to perform to actually perform the task that is the goal. And our users need to sometimes also change the layout of an application, and that required a lot of manual operations. And with auto layout feature, it's now possible with a single operation to change the layout of an application, to reorient in an application. During the experiment, we also had several stages. First, we provided an introduction video to ensure that all users had basic knowledge on our language and on our tool. Then we asked them to perform the maintenance tasks while an observer was summarizing in the interesting observation. A think aloud scribe noted everything that the participant said, and the moderator instructed the tasks and also reminded participants or asked questions when it was necessary. Afterwards, we performed a semi-structured interview, so we could ask users to reflect on their experiences during the experiment. Asynchronously, they also completed a questionnaire where they had time to, at their own pace, still reflect on some interesting questions. Afterwards, they got a solution video where we presented one possible way to solve the tasks. Now, I would like to present some selected results from our user studies. As I said, maybe some results might be relevant also for developers of other modeling tools. In the questionnaire, they had to answer about the strengths and weaknesses of the tool. They particularly noted that the structuring mechanism or the refactoring features that were offered were strengths of Fordiac IDE. Weaknesses were marked as search features or the layout of some certain aspects. They also marked as threats for using the tool in a commercial context that there is a small development community, and opportunities, though, are the platform-independent software that is independent of a concrete hardware platform. Results are, of course, contained in our paper, which was originally published at the Models Conference last year. Now, back to our cognitive dimension visibility. So in the study, each hierarchy level was presented in a new tab, and it was difficult to see the current location in the whole application. After the study, therefore, a new widget was implemented that shows the current path to the open element and also allows navigation. And as you see, only one tab is now open per editor, and that might help to find the required tab. Disadvantages are, though, that we cannot view diagrams side by side as easily anymore. So many of those cognitive dimensions come with a trade-off when they are discussed. We figured out also as a lesson learned that beauty is in the eye of the beholder, because while some industrial experts were actually satisfied with the results of the automated layouting, others were expecting a different arrangement. The developers are using a block position also to convey a meaning. For instance, we can create the block position based on the data connections here, but also focusing on the event connections. And this shows us that we have to integrate domain knowledge into the layout algorithms to best reflect the mental model of the developers. For instance, there is also a trade-off between the width and height of the diagram, but the details still remain an open question. Our System Explorer on the left not only shows the hierarchical structure, but it also contains the type library, so the library of all function block types that can be used inside the application. And the System Explorer was reported as specifically difficult to use. It has several purposes, like inserting an instance of a block type, which can be also done via the palette, exploring the library of project, which is also possible via the type navigator, or navigating through the hierarchy of the application. But especially this multitude of uses was confusing for the industrial experts during the study. Our experts also requested a variety of search features. Prior to the study, already a search feature was implemented for inserting a new type so that convenient search based on the name of the type is possible. But they also requested to search instances of a certain type, to search the instances by name or comment, also searching in the documentation, and many more. So this variety of search features that were requested were really surprising to us. Our industrial experts also requested that the tool is very graceful in handling incorrect models so that connections are not dismissed when they are becoming invalid, but the tool supports the engineer in fixing this problem. So as a new fix, error markers that show here in red problems in the model were introduced, but it's an ongoing investigation how to best visualize problematic model elements. Finally, to summarize, we can say that multi-stage usability studies are worth the effort. The tool has really changed significantly, and we have found a lot of interesting trade-offs in the cognitive dimensions. The cognitive dimensions also provided us a vocabulary for discussing these trade-offs, and the approach was really worth. It was worth to get feedback from industrial expert on the tool and the language. We could get feedback on our initial fixes, and also within the user study, we appreciated the multi-stage approach where we sometimes found differences in the results from the questionnaire and our own observations. So thanks for listening, and I'm open to questions.